Hello everyone, this is the first track of the introduction for the HFSS, which is the High Frequency System Simulations tools. And we will explain the tools, insert the HFSS design, drawing the geometries, and assign boundary conditions. So I'm gonna go over the HFSS. So this is the first page of the HFSS, and you can see the options for the files, edit, view, project, tools, window, and even you can get the help from this part, or you can press for the F1 to get the help. And on the down menus that you can see here, when you click on that, it will show you a couple of the options. This is the options for desktop, this is the options for the view, simulation, and automation, or the other steps that you wanted to do. So first of all, if you wanted to get the more options, you have to insert the HFSS design. So if I wanted to go to that, you can go to the setup, you can click on the HFSS, or you can go to the project and insert HFSS design. So I'm gonna click on that. So now as you can see, there's the window for the HFSS design with the full options that you can see for the drawing, for the view, and for the model, and even for the simulations that you can see here. So first of all, I want to go over the several steps that you can see here. We have the project manager. So you have the projects here. You can there's a tree for them. You can open them. You can see the component models, the circuit elements, boundaries, excitation, meshing, analysis, optometric tools, results, and port field display. So all the information that you wanted to get in your simulations are presented here. And the second window that you can see here is the properties, which is the properties of the variables or the materials. That if you click on them, you will see all the informations here, which it's a possible and feasible way to change them as soon as like in a faster way. And the other windows that you can see here is the messenger manager part. This window is showing you the progressing of your simulations and drawing. It is showing you the errors. If you wanted to see the simulations messages, you will see all of them here. And we have the progress part. This window is showing you the progress. It is showing you the passes that it's going to simulate. So you will see the progress here. And the main window that you can see is the main window of the structure. So in this window, you can see that what is your structure, and what are you drawing here. And so I wanted to go over one by one of these windows and explain which part is doing what. So here you can see, I'm gonna go to the desktop. You can here open a new files, or new open a file from the your saved data. So you can save it with this options, and you can see the HFSS, insert the HFSS model or the circuit models. All the options are here. And you can also play with the project variables here. And I will explain you in the parametric variables. So you can change the options here. The second option is the view. So in the view, you have the visual of your structure. You can change them. So here you can click on the model. You can hide it. You can show that model. You can show all of them, or you can here open the box and check which one you wanted to see. So before going over the all the options, I just wanted to model a couple of these things, and before and after go to show you the options. I'm gonna go to the draw. In the draw tab, you can see all the options, and here I wanted to like draw a structure. So I'm clicking on the draw box. So here you see the create a box. You can change this actually if you wanted to draw it on your on this window. So you can click on the F3 and on your keyboard, and it will give you the access to draw it here. So as you can see here, so as I wanted to draw it like parametric, I normally do the go with the second option. So if I click on this, so it is giving me this measure data. So it's showing me the measure data. If I click on the F4, I can see that it is giving me the option to define with the parametrics. So I'm gonna go with that. So I'm gonna put the length of the structure as L. So I'm starting from the L minus L over 2 in the X direction, and the Y direction I'm gonna put it minus W over 2. This is for the width, and for the height, I'm gonna start from 0 and go to the upper height. So now it's asking for the length of the L. So I can define it like in an inch or in a millimeter. So you can choose it here. So the parameter, the unit type is length, and the parameter is in a millimeter. You can change it for any other units that you have. So I'm gonna put it like as a 20 for the length and click on OK. So now it's asking for the W. So the easiest way, if you don't want it to go and select them, is like you can choose it like 15 and you can write it millimeter. So it will also check the length of the width. So now I'm gonna go define the x-axis length. So it is from minus L over 2 till L. The y-axis is from minus W over 2 till W, and the height of the structure is from 0 to, like, I'm gonna put it H as a height. So it will ask me the value for that. I'm gonna put it like 5 millimeter, as we choose the length before. So it is by default, it is selecting the length here. So I'm gonna click on OK. So here we already defined the structure. So what I'm gonna do, I'm gonna go over the attribute and change the name of the box. I'm gonna name it like rectangle. So here I can change the material. So by default we have the vacuum here, but you can select it by the edit. So I'm gonna mark it as a PEC. So as you can see here, and I click on OK. So as it is the PEC, so you are not able to solve inside. So I'm gonna uncheck this part, and here you can select the color of that. So I'm gonna mark it as a yellow one, and even you can make it transparent. So I just wanted to put it like a 0.4 and click on OK. So if you come here and then click on the fetal, it will show you the whole structure. So here, okay, we have two boxes. I'm gonna remove the box inside, and we have the structure of the PEC and the rectangle one. So also I wanted to draw a cylinder. Okay, I'm going to here draw cylinder. Click on that. So as I told you, you can name it parametric. So the center of the cylinder, I wanted to put in the center. Okay, but it will start from the, yeah, it can start from the 0. So the radius of the cylinder, I'm gonna put it as R. It will ask me what is the radius. So as the R is a famous variable in the HFSS, you can check, you have to change the name. R is RC. So for the RC, I'm gonna put it like 2.5 millimeter for the radius of the cylinder. As you can see the radius here. So the height of that is H, or we can put it 2 cross H, which is the double of the H. And then you can go to the attribute. You can name it like you can keep it as it is, cylinder. So the for the material you can change it. I don't know, maybe the maybe RO 4003. Yeah, you can select the substrate material here. Sorry, and then you can click on that. Also, you can change the color of that. I'm gonna change it to the green to be visible here. So as we wanted to solve inside and the dielectric material. I don't want to uncheck this one, so I'm gonna click on OK. So it is showing me this here, the structure here. As you can see here, the cylinder part is inside of the this rectangular part. So now I'm gonna show you a couple of the things. So in the view, you can go here, you can select the like the rectangle, and if you click on this, you can hide it. So it is the options that you will see here. If you click on this, you will show all of them, or you can, if you hide all of them, you can click on them, okay, and you can hide all of them, so you don't see anything. So here you can click on this box and it will give you the option to show. As you can see here, you can uncheck here to show them. So the other thing, you can check you rotate it like this. It will give you more possibility to check your geometry. And even you can click on this to see the front view, back view from this part. So it is giving you good options. I'm gonna keep it on a 3D mode. I'm going to the drawing. You saw all the drawings here, but there are, I explained you almost this part, but we have the options to move it, to rotate it, mirror it, as you can see here. So I'm gonna click on the rectangle. Okay. So we have, if you wanted to move the structure that you have, you can do any of them here. Like you can click on the move. It will give you the parametric option. Even here, if you click on the F3, it will give you the options on the window, but as I wanted to do it parametric, I'm gonna go here. So in the X direction, like in this direction or the Y direction, I'm gonna change to the Y direction. I'm gonna move it like as a move. Maybe I can name it Y move, and I can make this X move, and I can name it Z move. So if I click on this, it will ask me that what is the length, what is the unit type. I'm gonna mark it as a length. So I'm gonna put it like maybe 2 millimeter, maybe like 10 millimeter. So I'm gonna click on that, and for this one, I'm gonna even make it 10 millimeter and 10 millimeter. So as you can see here, it is going to the 10 millimeter in X direction, 10 millimeter in Y direction, and 10 millimeter in the Z direction. So if I click on that, it will go there, as you can see here. So I just wanted to go back to the first to the main place of the rectangle because I wanted to check other things. So it easily, I click on the HFSS here, so it is showing me the properties. As I told you, these properties are showing the parametrics. So I'm gonna go back to the original. I'm gonna change it to 0, 0, and 0. So you see that it's going to the original place. So it means that I'm able to change it with the parametric mode. So here, maybe you can make it 5. As you can see here, it is changing. Or for the age, you can make it, I don't know, 10. So here it's giving you the option. The other options that I wanted to go over them is the you can rotate it, or you can do you can do the rotation and the mirror here, but I wanted to check the unit because if you have the intersection between the two geometries, then you cannot simulate it. You have to solve the intersections always on the HFSS. I'm gonna click on the rectangle and cylinder, as you can see here. So I can make them one unit 5 unit geometry, like you unit them, unify them. So if you check here, now they are the same material, same unit, and they are in the material of the first option that we did. So if I go back with the Control Z, so the first one was PEC and the second one was the Rogers RO 4003. I'm gonna first click this one, which was in the green color. I'm gonna first click this one and second click on this one, and then unit them. So if you check, so the material is the material of the first option, first for our first choose. Okay, I'm gonna go back. So this is unified form of that. I'm gonna go back with the Control Z, and what you can do, maybe you can subtract from each other like a rectangle one and the cylinder. Like you can see the subtract option here. You can see the intersect option. If you like subtract it, you will see this page rectangle from the cylinder. Okay, you can see the subtraction. So this is the overall of the drawing for the model. You can make it a group like for the array antennas, or you can go over the simulation. If you go to over the simulation, you have the some parts that I will explain you. You have the validation part. So when you click on that, it will show you that what you need to explain for your antenna. Here it's showing me that the 3D model is not completed, the boundaries and excitation is not explained and defined here, and the analysis setup is missed. So we have three errors that we have to fix them. So first of all, I wanted to go back, like Control Z it, go back again. Here you see all the errors. I just wanted to clear the errors from the message manager, and if I click on the validate, it will also show me mm, 3D model problem because they are intersect each other. So they have connections here. We have to always solve this problem. Before going to that, okay, I wanted to subtract this one from this one. So I'm gonna go over the model and then subtract this one and click on, okay, I'm subtracting the cylinder from the rectangle, click on OK. So I have this one. First of all, we have to define the boundary conditions. Okay, for the defining the boundary conditions, we can uh, we can click on this here, create region. Okay, in the draw panel, we can go over the create region. So we are clicking on that, and it is showing me the percentage of the offset that we need because we wanted to put the structure in a box and simulate it. So I'm gonna put it like for now, I'm gonna put it like maybe 50%, and I'm gonna click OK. So it is showing me boundaries that it is like 50% offset from the edge side. So for this boundary condition, we have for this region, we have to assign it as a radiation boundary condition. So I'm gonna click on this one and right click on that, assign boundaries, and then go over the radiation. So if I click on that, it will define my radiation box. So now this is the radiation box, and if you go here, you will see the boundaries on that. So now we have the radiation box, we have the model, we need to define the excitation. So I'm gonna clear the messages here, and if I again go to the simulation and validate my structure, you will see that I solved the 3D model because 3D models need the radiation box. Okay, so now we have to go to the boundaries and excitation. So I already explained, assigned the boundaries. I need to put the excitation. So for the excitation, what I can do, I can put a sheet underneath of this structure, and then I can put a excitation here. So what I'm gonna do to be more clear for me, I'm gonna click on the region. I'm gonna go over the view. So I'm gonna hide this region of the radiation box. So now I don't see that one. So I have to put a wayport here. What I'm gonna do, I'm gonna define a circular sheet here. So I'm click on that. We have to define the position. The position was 0 actually, but the radius is the r under underscore c, and we can define the color of that. I'm gonna color it like with the red one, and it is the circle port. and yeah, it is a kind of the model. So I'm gonna just click on that, and as you can see, you see the sheet here. So now what I'm gonna do, I'm gonna right click on this one and select uh, choose the selection mode. So right click, select the mode, selection mode, and go over the faces because I wanted to select the face. Also, you can use the F to select the face. Okay. So now that I selected the face, I can easily just one click on this one. The face is selected. So right click on that and go over the excitation and go over the port. So you can define the port here, but here it is not showing me the wave port, and the reason is that it is showing me some kind of the terminals lamp ports. So, and the circuit port means that the HFSS solution is on a terminal, and I have to change it to the model. So I go to the HFSS, and on the underneath of the solution type, if I click on the model, then click OK, it will give me the option. So now we wanted to define the excitation. So I'm gonna press on F in my keyboard. So it will give me the option of the selection mode for the face. Just left click on that. You will see that the surface of the sheet is selected. So I'm gonna right click on that and go over the excitation port. And now you can see that we have the wave port option here. So I'm going to click on that. Sometimes you need for the wave port, you need to define the integration line. So you have the option here, but for my case, I don't want to do that because I don't need it. I just wanted to put it as none, and just click on the next. And here you can normalize it or renormalize it. I don't want to change all of them, just finish. So I'm gonna clear the error messages again here. So if I would go to the simulation, validate, you will see, okay, we have a must have solved inside. Okay, so there's a problem here. Whenever in the HFSS, whenever the port is inside of the radiation box, inside of the radiation box, so if as you wanted to define the direction of the wave that going, you have to put the PEC on the back of the port. So I'm gonna put the PEC on the back of that to because we have to do it in the HFSS to define the direction of the wave. Again, I'm gonna go to the view, go to the here. So I'm gonna hide the region, and so I wanted to put a cap before of this port. So then it's possible in the drawing. So go over the circle. It is the from minus minus like maybe 2 millimeters till the radius is the same radius r underscore c, and the height is the 2 millimeter as we had. So I'm gonna name it as a cap, and it should be PEC. So we don't want it to solve inside, and our PEC color was yellow color. So I'm gonna change it like to the maybe brown just to show it there. I'm gonna click on OK. So now it's showing me the cap of that. So now we can go again here and show up all of them. So I'm gonna clean these messages, and if I go to the simulation and validate the result, you see that it's been done. So now we need to choose the analysis setup and define it. So what I'm going to do, I can go to the HFSS. So in the HFSS we have the like a model, we have the boundary excitation, meshing, analysis setup, optometric analysis, and all the options are here. So as we wanted to go to the analysis setup, I'm gonna go here, add the solution. You can go with the auto, you can go with the advanced. I'm gonna go with the advanced. So in the advanced, you see the driven solution setup. You have the single. If you wanted to simulate in a single frequency, you have this option: all multi-discrete frequencies or the broadband simulation. I'm gonna go over the broadband maybe and put it like a lowest frequency from maybe 2, and the highest frequency you can define it like 5. maximum number of the passes. So this number of the passes is showing you that your simulations will can go like the maximum number of the passes. I'm gonna put it like 10, and maximum delta this is for the error function. So whenever it's less than the 0.02, it will show you that your results has your simulation is converged. Then you can simulate the structure. So on the second option of that, you have the options for the minimum number of the passes. So we define that at least like one or two passes should should be done in the simulation. I normally put it like two, and the minimum convergent passes after the minimum number of the passes is showing you that if two passes sequentially go converge, then the simulations can start from there. So I'm gonna again put it number two. So here you can select the solution options. You can do the zero order, first order, second mix. If you need more information about them, you can check the HFSS PDF file. So I'm gonna put it like as a first. Here you have also the other options for them. I don't want to change any of them. Okay, just click on that, and you will see the edit frequency option. You can see the sweep file here. So it is from 2 to 5. The point is 405, 401. I just want to decrease the point to 201. And you will see you can save the fields at the basis frequencies. So normally we need to save them to check the fields at the results. I'm going to click on OK. And I think that it's overall for the simulation part. If you go again to the simulation and validate it, you will see that everything is fine. And now you can click on the analysis all, or you can go to the analysis, right click on the setup and analysis, start the simulations from here for the analysis of your structure. This is the overall of the introduction for the HFSS, and so the other parts for the results and the simulation of the antennas will be explained on the next episodes. Thank you for watching.